Welcome to the Explainer. Today, we're going to tackle a challenge that, let's be honest, probably keeps a lot of developers up at night, trying to manage the chaos of microservices. We're going to build the modern playbook for taming that complexity, using some really cool tools that bring order to all that madness. All right, let's just dive right into it. Picture this. Your app isn't just one big thing anymore, it's a whole fleet of tiny, interconnected services. So when you want to push a single update, you're not just updating one thing. You're trying to orchestrate this really complex dance between all of them. And if you make one wrong move, well, the whole system can come crashing down. So how in the world do you manage that without taking on massive risk? This right here is the puzzle that developers are staring at every single day. Each of those 10 microservices has its own deployment files, its own configurations, its own little quirks and dependencies. And if you try to manage them one by one, you're going to end up with this tangled, knotted mess. A change over here could totally break something over there. It's just a high-stakes, super stressful situation that's begging for a human error. So how do we solve this? Well, our first tool is something called Helm. And the best way to think about it is like an IKEA kit for your application. It packages up everything you need, all the parts, all the instructions, into one single manageable box. At its core, Helm is the package manager for Kubernetes. And Kubernetes, as you probably know, is pretty much the industry standard for running and managing modern applications. So just like you'd use an app store to install something on your phone, you use Helm to install, upgrade, and manage even the most complicated apps inside a Kubernetes cluster. It just takes all those scattered pieces and bundles them together. And that box, that neat little package we've been talking about, that's officially called a Helm chart. This is the key concept we're going to be working with. It's the complete blueprint for your entire application stack. Okay, so let's peek inside one of these Helm charts. First, you've got Chart YAML. That's basically the label on the outside of the box with the name and version. But the real magic happens between the other two. The values YAML file is where you can tweak all your settings, like, say, I need 3 copies of this server running. Then the templates directory has all the raw Kubernetes instructions, but with little blank spots. Helm takes the settings from your values YAML file and uses them to fill in those blanks, creating the final deployment files. Pretty cool, right? So we have our application packaged up, all nice and neat. But now what? How do we get it from a developer's laptop into a live production environment and do it reliably every single time? For that, we're going to need an automated assembly line. And this is where Azure DevOps comes into the picture. It gives us what's called a CI/CD pipeline. CI/CD stands for continuous integration and continuous deployment, which is really just a fancy way of saying we're going to automate that whole journey from a developer's keyboard all the way to the end user. It is the assembly line for our Helm package. So here's how this assembly line actually works. A developer commits their code. That single action automatically triggers the pipeline, which builds a new container image. You can think of that as a little self-contained box with the application code inside. Then, that image gets pushed to a registry for storage. And finally, Helm grabs it and deploys the updated application chart. The whole thing, from code to production, is completely hands-off. Okay, that workflow sounds fantastic. But we all know the real world is a bit messier, right? We've run into challenges. How do we handle secrets without exposing them? How do we make sure our pipelines are actually efficient? And how do we stop ourselves from just copying and pasting the same code over and over again? Let's tackle these one by one. First, and this one's a big one, security. Your application needs secrets, database passwords, API keys, you name it. And you absolutely, positively cannot just store these in your code or in a plain text file. So, how do you manage them securely in a fully automated pipeline? Well, you could just use simple pipeline variables for secrets, but honestly, that's pretty risky. The real best practice is to integrate with a dedicated tool like Azure Key Vault. It's a centralized, super secure vault with really strict access controls and audit trails. Your pipeline gets temporary access to pull secrets only when it absolutely needs them, which is a much, much more secure way to do things. All right, next up, efficiency. A lot of teams nowadays use what's called monorepo, where all the code for all the microservices lives in one giant repository. And that's great for collaboration, but it creates a brand new problem. If a developer changes just one line of code in one single service, do you really want to rebuild and retest all 10 of them? Of course not. That's a huge waste of time and computing power. The solution is actually pretty elegant. Path-based triggers. You just configure your pipeline to watch specific folders.
So, a change in the microservice B folder only triggers the pipeline for microservice B. All the others are left untouched. This makes your whole build process way faster and a whole lot more efficient.
And finally, let's talk about reusability. Your deployment logic for your development environment is probably 95% the same as it is for staging and for production. The absolute worst thing you can do is copy and paste that logic into 3 different pipeline files. It just becomes a total nightmare to maintain.
The answer here is to use templates. You define all that core deployment logic, all the shared steps in one single reusable template file. Then your main pipeline just calls that template for each environment, dev, staging, prod, and it passes in the few little parameters that are different, like a server URL or a replica count. You write the logic once, and you reuse it everywhere. It's a game changer.
Okay, so we've covered packaging with Helm, we've automated with DevOps, and we've solved some of those common real-world headaches. Now, let's zoom out, connect all the dots, and see what this complete modern deployment workflow really looks like.
And here it is, the whole system in action. Your code is in a monorepo. A commit to a specific folder kicks off its dedicated pipeline using a path trigger. That pipeline uses a reusable template. It pulls its configurations and secrets from secure sources like Key Vault, and then, at the very end, it uses Helm to package and deploy the application. This is the blueprint for a deployment process that's secure, efficient, and actually maintainable. So you've done it. You have absolutely mastered the modern deployment playbook. Your pipeline is a beautiful work of art. But this victory immediately brings up the next critical question. Now that your application is live, how do you know if it's actually healthy? How do you monitor its performance and catch errors before your users do? Your deployment is automated, for sure, but is it observable? Well, that's a topic for another day.